again, take out the packets and show me that you did pages 3 and 4.
And like computer 5, and then I read the email. So I stopped.
Sorry, I got you late. Why did it colored in?
But I really do not understand, like, what is
So like there should be a line here. Okay. 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 So that makes sense.
Yes, no? Through 3 and 4. Through 4 and all your Okay, we're gonna go over. Gene.
Oh, sorry, I'm the last one. Yes. Okay. All right. First of all, those of you who are new, welcome. I'm Miss Pascal. Hey, we'll chat in a minute. But I want to get started with today. We are going to have an exit card, and I'm sorry, even if you're brand new here, I just want to see what you can figure out. Homework is to finish through page 7. And yes, we're going to go over page 3 and 4. I believe we did some of this yesterday. So, some of you don't like the idea that if it doesn't have an actual dot on it, does the point exist? Well, there's an infinite number of dots on this line that it's easier to just draw the line. And what is the y value when x is negative 4? Well, it appears to be 3. What is the y value when x is negative 2? I don't know, 2.5, something like that. I don't need to actually have a dot on there. So answering number 1, as we approach negative 9 from the side that has negatives, so that's over here on the left, I'm going to follow till I get to about where x equals negative 9. Where is the y value? It appears to be negative 2. Are we okay with that idea? Eleanor, yeah? Cleo, yeah? So then now, all right, what's the y value as we come at negative 9 from the other side, from the right, from the positives? Same road. It also appears to be coming up to negative 2. And then where is the function at negative 9? I didn't draw the dot, I didn't put a big fat circle on it, but it is colored in there. It does exist. So it's negative 2. So what the kind of discontinuity is there, Emery?
Sorry, it would be
Is it discontinuous? Could I draw that whole thing without picking up my pen, or is it removable?
removable.
It's removable? Alistair, you seem to disagree.
Well, I would just disagree because you could draw the line.
Because I can go happy face line. It's continuous. No discontinuity. I didn't have to pick up my finger. So this is the definition of continuity that I asked you guys to write down yesterday. The limit from the left side goes to some number. The limit from the right side goes to that same number. Oh, and the function is colored in there as well. No problem. You can draw that whole thing over. Emmanuel, question? No? Okay. All right, at x equals 0, so those of you who are new, can someone explain to them what that little minus means, Abraham? Can you tell us what that means?
Dang, I was actually excited for somebody else to explain because I'm confused about this recently.
Okay, Rakib? No, don't know?
Is it linked to the left?
Yeah, it means from the left, because it means from the side that has negatives on it. Negatives are on the left, positives are on the right. Okay, so left and right of what? Whatever that number is. So at 0, from the side where the negatives are, so on this side is 0. As we get really, really, really close to x goes to 0, what is that y value going to? 2. Okay, 2. Perfect. And now, going to 0 from the other side, from where the positives are. You're blindfolded. Where would you guess? Claire, where would you guess that your foot is going to hit if we're coming at 0 from the right-hand side? 4. 4. But where is it actually colored in? Where is the solid dot? The solid dot is down here at 2. So Lidette, could I draw this whole thing without picking up my finger? No. So there is some kind of discontinuity. Is it removable, jump, or infinite?
Yeah, it's a removable jumper.
Which?
It's jumper.
It's jump. It can't be removable and jump. It's a jump, because I couldn't have built a bridge. That would be a ladder. Your car is not going to crawl up the ladder. That is a jump discontinuity. One side went to one number, the other side went to a different distinct number. They're not the same. It's a problem. Questions about those? All right, check your answers for this page. Do you still have questions on the page? So that going along towards 0, so x equals 5, 4, 3, 2, 0 from the right. Okay, right about where x is 0. What does that y value seem to be? this is telling you what x value we want you to go towards. So find that on the graph, -9. X is -9. Where's the graph? There, right here. So the left side come down, the right side going up. Where does the y value appear to be? As you guys sketched out, right there, it looks like it's at -2 from the left, -2 from the right, and the function's even drawn in there. This one, okay, where we wanna be, x is 0, it's this guy. From the left, this side. From the right, that side. And then which one is it actually colored in? That's the dot that's all. Good? So you're ready from where? Alright, and where do you start school there, or you were in that? I mean, this year. But are you coming from Mr. Carlos' class, Yes, are you doing this question? Okay, so let's go over it. Yeah. All right, so some of you are like, no idea what's going on. Okay, let's check it out. So the ones that are asking just where is the coordinate? These guys. Where is the coordinate? So when x is 0, okay, when x is 0, what space is colored in? 4. So when x is 0, the y value is 4. The lines are going different places, but actually colored in at that point is a 4. Here, f of 6, here's x equals 6. There isn't a dot specifically on the graph, but the graph goes, like, every dot exists there. And that guy appears to be a y value of 3. Okay, this one, at -4, these guys are, there's an asymptote. Yeah,
I have a question for number 5.
okay,
Yeah, because you say that the point doesn't exist, even though -2, there is a colored in point at -5.
okay,
So I just
Hold on.
don't understand that.
okay. Hold on, Fernando, you have earbuds in? No, thank you. Here at -4, this is a vertical asymptote. There's nothing colored in anywhere. There is no dot colored in for that. Number 5, it's not what is the function there, it says what is the limit as we go to -2. Alistair, am I telling you what direction to approach this from?
Nah.
No. So I'm gonna say, you're on the right side of -2, and Eleanor, you're gonna be on the left side of -2. Are you guys going to the same place? No. So, Martha, when I just say at -2, like as you're approaching -2, I'm not gonna tell you, I'm not gonna be nice and be like, you're coming from the left, you're coming from the right. It's just, you're going at -2. Where are you gonna end up? If you are using your fingers to go at this from both directions and your fingers aren't in the same place, you gotta
That'd be
say.
a jump, right?
Yeah, it could be infinite as well. This one, I don't know. It could be 0, it could be -5, I don't know. Alistair, what's your question?
Yeah, could you go over number 7?
Okay. Martha, I'm not sure I answered your question though.
No, it's okay though.
Okay, number 7, let's look at number 7. Yesterday I talked about how the ... that's implying to be a horizontal asymptote, that the function's flattening out to that height. So this is at x equals 8 and it's right there. Kinda, that dot 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 is implying that that line is gonna level off there, yeah.
But won't the line like never touch the asymptote though?
Okay, one thing, we lie to you, it can cross the asymptote, but, you're right, it doesn't actually touch it, but are you going to say 2.00000000000000001?
No, I had wrote infinity because I just thought it was never gonna touch it, so I just keep going.
Okay.
Along that line.
Where is y equals infinity?
That does not, yeah.
Where does y equal infinity is way up there. So what's a better description? You're telling me the x value. I don't want the x value. This, where did it go? Which question are we on?
7.
Thank you. So when x goes to infinity, where's the y value? Well, it's looking like it's settling down, got a dog, got a house, it's at 2. It needed a dog, yeah.
So how come when it didn't have like the plus or minus on number 5, it was DNU, but for the other ones, if it doesn't have a plus or minus, it can still happen?
Okay. So first of all, there's a difference between what is the limit, that's the, I'm not touching, I'm getting really, really close, I didn't touch, I'm really close. That, the limit from this side of 0, as I come at 0 from the right, I'm getting really, really close to 3. Where is the function at 0? Where is f of 0? Where is it actually colored in? It's colored in at 4. But the limit from the right of 0, should I even ask that? This didn't say left or right, so before I had Alistair and Eleanor coming at things from different sides. Remember, just a sec. But here, I don't tell you which side you're coming from, but are you going to the same y value, or are you ending up in the same place? So that one's gonna be a 3. What were you gonna say?
I'm gonna go over
11, okay? Did I finish answering that?
Yeah, kind of.
Yeah, kind of. Okay, as we go at 5, so I didn't tell you which side, right? So I'm gonna use 2 fingers. I'm gonna go from the left and the right of 5, and I'm gonna get closer and closer to 5. Are my fingers going in the same place? So then I'm not telling you which way you're driving. You can't tell me where you're gonna predict where you're gonna go. That one doesn't exist. Okay, what else? There's lots of crazy business, Cherry. 1. So same idea with the positive infinity. This dot 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 line means it's a horizontal asymptote. This y value is settling off out this way. How high does that appear to be? At -3. So when we get super far down the road, be like, how high is it? -3. Still? Yep, still. And Alistair doesn't have to touch it, just gets close. Abraham?
I don't understand this. Can you go over like number 3?
Okay, -2 from the left. All right, let's find -2. -2 from the left, that's over here. So I'm coming at it this way. I'm not anywhere near -2, not anywhere, okay, now I'm getting close to -2. Where does the y value from this direction appear to go?
To -2. Oh,
To
to the y value?
The y value,
It's -5.
yes. So as the x value goes to -2, where is the height of the y value?
We're not going that direction, we're going the other direction. We're going.
For number 3,
I know, it says to go from the negative, but that arrow is going towards the, is going the opposite direction.
this arrow in the symbol,
No, the other
I
arrow
was
on
talking
the
about
left.
the
Arrow
arrow
on the
on
graph.
like the bottom, but I think that
So can you go backwards up then?
that just shows that it goes on forever.
okay. So if I was to draw this from left to right, I'm coming from -3 out at that negative infinity. This goes down forever. I need to stop drawing. I'm gonna, because there's a break,
Right.
there's a discontinuity at -4. And then I come up. So going left to right, I had to draw it this way.
So you can go either direction.
Oops, got it.
It just depends on which direction like the negative is on the actual like equation.
Okay. This is not where x equals -2, so I'm gonna not even bother, don't be upset that there's an arrow.
I think I get it now. I see where you get the -5 from.
So, this was -4, -3, -2.5, -2.1, and at -2, the height appears to be -5.
Thanks for.
Cool. Alright, what else? Because some of you are very unhappy with this page. Feeling slightly better? Less uncomfortable? Eleanor?
Like, I was just, confused at the describe the behavior.
Okay.
Because describe the behavior when, the vertical asymptote is x equals 3, how do you?
Okay, so, you guys have seen the graph 1/x before, yes? That's got a vertical asymptote. And if I tell you a function has a vertical asymptote, we want you to know that one side or the other of that asymptote is going to go to some infinity. That's all we really were asking you to say, is from the left or the right of wherever there's vertical asymptote at D, okay? So on the left or right of D, the y value is gonna go to one of the infinities. That's all we wanted, was to have some idea. Yes? Number 2? Okay. This says, I'm gonna walk towards -4. Here's x is -4. From the side where positive numbers are. Are positive numbers on this way or this way? This, okay. So I'm gonna come at -4 from the side that has positive numbers. So I'm gonna start here and walking towards it. Where does the y value appear to be going? Where is down? What number is super down forever? There you go. Negative infinity, yes. Yeah? All right. Yes, Alistair.
Base recipe.
Yeah. You need to fill it up. Okay, I'm gonna skip the top part of page 5, and we're gonna jump to the bottom. Number 2, we're gonna try these without graphing. So, Khalil, left side. Is the left side numbers less than 1 or numbers bigger than 1? Less than 1. And I have dyslexia. I see things backwards and mess up left and right. This is actually hard for me. I hate from the left and the right. So those of you who are like, oh, I can't do this, I'm no good at math because I have dyslexia. So what? So do I. Get over it. Heard the excuse. Get over it. Okay, so the left side, numbers less than 1. So, anyone got an idea how we're going to fill in that number? Ahmed, got a guess? Khalil said, this is the equation for the left side. So plug in the number that we're approaching. So plug in 1 for x, what do we get?
1.
Plug in 1 for x and we get
6.
6. 5 times 1 plus 1.
But it
Check.
shows less than 1.
But, yeah, it doesn't include 1, right?
Okay. So hold on, what was-
How do you know which one to use?
okay. Khalil, how did you know the top was the one for the left?
Because it's, less than 1.
Okay, here's one. If I want to know the limit of this stuff, numbers coming at it from the left, Khalil says numbers that are smaller than 1 are on the left side.
Because it's negative as well, right?
Sure. So you're right, I don't have an equal sign for the 1. But if I wanted to know, like, sorry, you're in this seat. I'm not touching, I'm getting really, really, really close. If I was actually to make contact, if I was actually be able to take that step to x equals 1, what value would you have gotten? You're right, on the graph it's going to be a big old hole, but I would get really, really, really close to that. Louisa, so if this is the left side, I'm guessing this is the right, because Numbers that are bigger than 1 are on the right. So how am I gonna calculate that value? Okay, so here's the equation that is on the right. What is the value of x where this breaks? What x value makes it break? It's written in the piecewise function. 1. So plug in 1 for x into that bottom equation. What y value did we get? 6. Mod, is there a equals in there anywhere? So what does the function equal when x is actually 1? Do I tell you when x is 1 what the value is?
No.
So do you get to just pick one, or do you have to say, I don't know? This one, it is not defined. I didn't give an equals. Manuel, you're looking at it like, If I told you equals on one of these, then you could plug in, but I didn't give the equals anywhere. No, not making any sense? Claire, how you doing? Okay. All right. Okay. Do you guys at least understand why Khalil chose this as the left side? And why that's what we're looking at? Yeah? Okay. And this bit is the right side of one. And because they're limits, so Ahmed didn't like it that, well, but there isn't an equals. So how do we, why are we plugging in the actual one? Well, Ahmed, if I plugged in 0.9999999999999 times 5 and add 1, it's gonna be 5.9999999. Might as well just call it 6. That's what limits are. It gets really, really, really close, but it doesn't actually touch. All right. Why does this make this a discontinuity? Yes, Claire?
So on the graph, would it have a hole at 1 and 6?
There would be a hole at the coordinate 1, 6. So if I could glue something in, or where is the hole? She just told us the coordinate of the hole is 1, 6. This is a removable discontinuity. And yesterday we went over the definitions of what makes something a removable discontinuity or a jump discontinuity. Removable is the limit from the left and the right are equal, and the function is not wherever that guy is. Louisa, you remember that at all yesterday? I saw notes, you had things written down. When does lunch start today?
13. Oh, no, 13.
Yeah, 13. Okay. Which is not quite yet. But I do need to let you guys have time to do the exit card. It is not. So you guys are responsible for finishing through page 7. Can you put your notes away?